So here we're going to be given a polynomial and a factor of that polynomial. This x plus 4 is one of the factors, which means we could say x plus 4 times something would equal this original polynomial x to the third minus 4x squared minus 41x minus 36. Our job is to figure out what is this second factor that multiplies with the x plus 4. And the way that we do that is not through grouping. What we would have tried is, because there's 4 terms, we would have tried to split it down the middle. But 41 and 36 aren't going to factor out so that we have a 4 and a 1 here. So factoring by grouping is not going to work. The only way through it is division, and we can choose long or synthetic division. And because this is a linear factor, we're going to choose synthetic division because it's faster. So first thing with linear synthetic division is we say x plus 4 equals 0, and you subtract the 4 to solve for x and get x equals negative 4. That number goes in your little half box thingy, and we bring down all our coefficients from this polynomial in order. So we have the 1, the negative 4, the negative 41, and negative 36. You give yourself a little space and draw a math bar because we're going to do some math. You bring your 1 down. Every time it's always first term down, and then you multiply by the negative 4 over here and bring the result underneath the next coefficient, which in this case would be negative 4. And then we add, and we get negative 8. And we repeat the process over and over. Take the negative 4 times by negative 8 here, and that's going to get you a positive 32. And then we add, and we should get a negative 9, and repeat. When we multiply there by negative 9 times the negative 4, we should get a positive 36, and as expected, we get a 0. Now, if you weren't expecting a 0 there, we need to, because it said it was a factor. Whenever it says it's a factor, the remainder must be equal to 0, which means it's a factor. So that was a check mark. Anyway, these 3 terms are supposed to go 1 degree less than what we started. We had a cubic, and we divided a cubic by a linear, which means that we should have a quadratic result. So that means these terms should get an x to the second as the highest degree. Next one down would be x to the 1, and then x to the none, because we go in descending order down to 0. So all of that goes up in my box up here to be the factored form, x squared minus 8x minus 9. So this original cubic 4-term polynomial can be factored as a product of a 2 by 3. Now, our job was not just to write it like that. It says find all the zeros algebraically. So our job is to continue to factor. So we've got one linear factor, which gave us it's going to give us an x-intercept of negative 4. And we've got to look in here at this quadratic and find some more. So we could use the quadratic formula if we liked, or better, we're going to do the magic x. So what we want to do is take this x squared minus 8x minus 9 and do the magic x with it. So I'm going to erase this synthetic division work right below it, a little bit of it, and do the magic x. So on top of the x is going to go negative 9 times the 1, so negative 9. And then on the bottom is negative 8. And our magic numbers should be 9 and 1, the 9 being negative, the 1 being positive, which means that this, because we have an a value of 1, we can just jump right to the factors from the magic numbers. We don't have to do the grouping step. So we say x minus 9 and x plus 1. The biggest mistake students make is they'll jump down here and say, oh, my answers, my zeros, they're negative 1 and 9. No, they're not. They are the factor numbers. The magic is just to call them the factors. So my factored form, fully factored form, if I just bring down my x plus 4, I will have my fully factored form. And to find zeros of a polynomial, you're supposed to set the polynomial, this is the factored form of the polynomial, equal to 0, and use the zero product property to solve. So we set each term equal to 0. We already set the x plus 4 equal to 0 and solved that and got a negative 4 out of there. And then we get x plus 9 equal to 0, and we get x plus 1 equal to 0. So my 3 roots, this is going to be a negative 4, a negative 9, and, or sorry, that was a minus 9, backing up one step. Why did I do that? So we set each one of these equal to 0. X plus 4 equal to 0, and solve that to get x equals negative 4. We set x minus 9 equal to 0, and solve and get x equals 9. Set x plus 1 equal to 0, and get x equals negative 1. My three zeros result to be negative 4, positive 9, and negative 1. Later we're going to learn that that's the beginning of us graphing a rough sketch of our polynomial function.